Hi everyone, in this video we are going to talk about special right triangles. Alright, so with special right triangles, I like to say it's as simple as 1, 2, 3. And the reason why I say that is because I don't really like to use formulas in this case. Like you won't see an X in there, for example. But I like to just use relationships. Okay, I feel like it's a lot simpler to just look at these as relationships. All right. So there are really two different types of special right triangles. The first type is called a 45, 45, 90. And that stands for 45 degrees, and 90 degrees. Okay? And the second one is going to be your, I guess we'll do this one over here. That one is going to be 30, 60, 90. And that is stands for 30 degrees, 60 degrees, and 90 degrees. So let's go ahead and create some of these right triangles. So that way you guys can see exactly what I'm talking about here for these relationships. What are the relationships? All right, so I'm going to draw this out. And so this one here is going to be our 45, 45, 90, which means that this angle right here, let me go ahead and change the size of my writing tool there. So anyway, so that means that these two angles are 45, meaning they're equivalent, and we have a right angle in here, which is 90. Now, when I'm defining these, it's actually, let me hold on one second. Sorry, I'm just getting my pen ready. I always start in the same spot, whether it's a 45, 45, 90 or a 30, 60, 90, and it's with the 1, okay, in this 1, 2, and 3, okay? And so basically, the smallest or the shortest leg always gets a value of 1, always. And so I'm just going to label this as 1. And actually, you might already see that with a 45, 45, 90, these two legs are actually equivalent. So if this leg is 1, then this leg is 1 as well because they're both the shortest leg. They are equivalent. Okay? And so where does the one, this is 1, 2, 3 come into play? Well, actually, the 45, 45, 90 is so simple, it doesn't even use the 3. It just uses the 1, 2 and the simple 1, 2, 3. And you can think of it as the 45, 45, 90 is the simple one, so it gets the simpler rules. So in this case, the length of our hypotenuse is actually the square root of 2. And I want you to think a little bit about why this makes sense. If I went ahead and calculated the square root of 1, that's equal to 1. Well, what's the square root of 2? What's the square root of 3? What's the square root of 4? I'm not going to actually calculate these out, but I know that the square root of 4 is 2, right? And I know the square root of 2 is going to be 1 point something, right? And also, square root of 3 is going to be 1 point something. It's just going to be a little bit more than the square root of 2, all right? But ultimately, I know that the square root of 2 and the square root of 3 are somewhere in between 1 and 2, all right? And that's kind of just an important concept to understand, okay? And let's go back to the 45, 45, 90. The square root of 2 is, yeah, it's a little bit bigger than 1, which makes sense. The hypotenuse should be bigger than the legs of these right triangles, okay? But anyway, so let's go back. It's as simple as 1, 2, 3. The short leg is 1, and then in this case, each of these has a square root, so you know the square root is going to go with the other one, which goes with the 2, okay? All right, let's go to the 30, 60, 90, and I'm going to go ahead and make this triangle. So kind of make it close to a 30, 60, 90, as close as I can anyways. So here is going to be my 90-degree angle. And let's go ahead and label our 30 and 60. The short, or the small angle is going to be, whoops, still got my line tool on. 1 second. That's going to be my 30 degrees, and the bigger angle is going to be my 60 degrees. Okay? All right, so let's go ahead and figure out how to label these. Whoops. There we go. All right, so I always start in the same place. It's as simple as 1, 2, 3. 1 is the short leg. Well, the short one is right here across from the 30, right? That's the short angle. It gets the short leg, and you can visually tell as well that that it's shorter, right? And let's see here. The longest leg is the hypotenuse. And I know that the longer one is actually double the shorter one in the 30, 60, 90 in this relationship. So this goes from 1 to 2. And then the last one, remember I said each of these gets a square root, and the only other number left is 3. So the last one is the square root of 3, which, by the way, I know this is logically correct because the short one is 1, the long one is 2. This one, just based on proportions here, it has to be between 1 and 2, and I showed you over here that the square root of 3 is somewhere between 1 and 2, so it makes sense. Okay? So there you go. These are the relationships. It's as simple as 1, 2, 3. The 45, 45, 90 just gets the 1 and 2. The 30, 60, 90 gets the 1, 2, and also the 3. Okay? All right, let's go ahead and we're going to do some very quick examples of how you would use these relationships in problems. So I'm going to create an example problem down here. So we'll say example for the 45, 45, 90. So I'm going to go ahead and create a small triangle here. And since these are equivalent, they have to be, these angles are equivalent, this has to be a 45, 45, 90. Now, if I gave you, let's make something up here. If I said this length is 9, the question is, what is the length of this side and what is the length of this side as well? Well, first of all, the length of this side is equivalent to 9, right? Because these are the same. And then based on our relationship of the 1, 2, 3 rule here for 45, 45, 90, how did I get from a short side to the hypotenuse? Well, I multiplied by the square root of 2. Didn't matter if this thing started with, if it started with 5, then this would be 5 times the square root of 2. If it started with 500, it would be 500 times the square root of 2. The relationship holds. Okay? So in this case, this is equivalent to 9. The short leg is 9 times the square root of 2. And there we go. So give me 1, and I can figure out the other 2. All right, and then let's do our last one example here, our last example for the 30, 60, 90. And so if I gave you this triangle here, it's a pretty terrible triangle, but whatever. And if I said this is 60 degrees, well, this one has to be 30 if this one's 90. But let me just see if I can just straighten that out just a little bit. Oop, that's not very good. Whatever. Anyway, so let's use this example. Let's say, I don't know, let's say I said this is 10. Okay? And if this is a 30, 60, 90, what is the length of this side and what is the length of this side? Well, the easy one is going from the short to the longest. The shortest to the longest is double. So if this is 10, then the hypotenuse must be 20. And then going to the middle, well, how much in the middle? Well, I mean, I'm not really sure, but I am sure. I know the relationship. I went from 1 to the square root of 3, or 1 times the square root of 3. Didn't matter if this started with 5, right? It would be 5 times the square root of 3. If it was 500, it would be 500 times the square root of 3. The relationship, again, still holds. All right, so this is going to be 10 times the square root of 3. Now, these can get a little bit more complicated. Like, for example, if I gave you the length of this side, how would you go to the short side without knowing it? Well, then you do the opposite, right? You'd have to, I multiply by square root of 3 to get there. I'd have to divide by the square root of 3 to get back. So they can get a little bit harder, but no matter what, the relationship still holds. And again, always keep in mind that this is for special right triangles. It's as simple as 1, 2, 3. The 45, 45, 90 is the simple one. It just gets the 1, 2. The 30, 60, 90 is the little bit more complicated one where it gets the 1, 2, and the 3. And just remember your relationships, and you'll be all set.